So in mathematics, a lot of times we have to solve simultaneous equations. Now, when I first started learning about simultaneous equations, I had no clue what they meant because I was thinking, how would you solve something while simultaneously solving another thing? How is that possible? I guess I came to learn that it is solving two things at the same time. However, it's not as difficult. It's not like you have to think of two things at the same time. It kind of rolls out in front of you. So for instance, you might be asked this kind of question. So solve the equations 2x take y equals 4 and x plus 2y equals negative 3. So the way that we usually do a question like this is maybe we'll write them out. Once we've written them out, we want to get one variable on its own. What that means is I might pick an equation. I can pick either one. It doesn't matter. I usually pick the easier one, and as you get into these simultaneous equations, you'll get to know what an easier equation would be. In this case, the x, I can see it's by itself, whereas this one's a 2x. So I'm going to pick this equation to manipulate and get maybe x by itself. Just having a look at this, I'll call this equation 1. I'm not going to call this equation 2 just yet. I'm going to change it a little bit. So what I'm going to do is I'm going to bring the 2y over to this left side. Now how I do that, and the reason why I do that is because I want to get this x by itself. And if I bring the 2y over, the x will be by itself. So to bring the 2y over, it's plus 2y, so the opposite of that is minus 2y, and minus 2y to each side. And now that'll cancel here, and I'll be left with x equals negative 3 minus 2y, like that. And see how I've got my x by itself now? So now what I can say is, well, x is actually equal to negative 3 minus 2y. And I'm going to call this equation 2. In this first equation, we've got x's and y's and numbers. And in the second equation, we've got x's and y's. But this x is by itself, and it actually is equal to negative 3 take 2y. So what I can do is I can substitute negative 3 take 2y into this x that we have up here. So what we do is we write substitute equation 2 into equation 1. And so for this equation 1, wherever I see an x, so it starts with a 2, wherever I see an x, I replace that with negative 3 minus 2y, because x equal to negative 3 take 2y. So I put in negative 3 minus 2y in for where that x used to be. It was right next to a 2, and that 2 is timesing, so that 2 times is onto everything inside these brackets. And then we've got a minus y, and then an equals 4. Now once we've done our substituting, what we have to do is get y. We can notice how what's happened is, in this new equation we have, there's only y's remaining. There's no x terms. There's just y's and numbers. And what that means is we can rearrange this, manipulate this equation to get y, to find what y is. And so the main strategy is to just get y by itself. Now I can't, this negative 2y and this minus y are separated by this these brackets here. So first I actually have to expand these brackets. So I'm going to multiply this 2 onto these two terms. 2 times negative 3 is negative 6. 2 times negative 2y is negative 4y. Then we've got a minus y, and that's still equal to 4. Now, we might group like terms. Now, this y and this y are both like terms, so negative 4y's minus 1y's. So that gives us negative 4 minus 1 is negative 5y's. Still got a negative 6 here. That's still equal to 4. Now my aim is to get y by itself. And I haven't done that just yet. So to get y by itself, I need to get rid of this negative 5 and also need to get rid of the negative 6. So first I might get rid of the negative 6. So the opposite of negative 6 is plus 6. So I'll plus 6 to each side. That'll cancel here. And I'll be left with negative 5y equals 4 plus 6 is 10. Now to get rid of the negative 5, it's timesing onto the y, so the opposite of times is to divide by negative 5 on each side. Now those cancel, so the negatives, leaving 1y equals 10 divided by negative 5 is negative 2. Now I have my y. That's pretty cool. But I want x as well. And that is the aim of solving these simultaneous equations, is we want both the x and the y. So I've got y, it's negative 2, but I haven't got my x yet. So what I can do is I actually put my y into equation 2 or equation 1. It actually does not matter, and I will get my x value. So I'm just going to choose equation 1 because it looks a bit harder, and I just want to do a proof of concept really. But putting negative 2 in for y here would actually be will give us the same x value. If we put negative 2 in for y there, we get negative 2 times negative 2 is 4, and negative 3 plus 4 is 1. So we're expecting x to equal 1. So this equation 1 should give us the same thing. So that's 2x take y equals 4. So 2x minus y is equal to 4. Now y we found is equal to 2. So we can put that in to that y right there. So we replace that negative y with negative, and then where the y is, we put negative 2. And that's equal to 4. Now we still haven't found x yet. Now a negative and negative, that'll make a positive 2. And that's still equal to 4. Still got the 2x. Now we'll bring the 2 over the right side, so we'll minus 2 from each side. That'll cancel here, and we get 4 minus 2 is 2. We've got 2x equals 2. Now this 2 is timesing, so we'll divide by 2 on both sides. They cancel, and x equals 1, which is exactly what we thought it would be in equation 2. So you can put your first variable that you find, and we could have found x first. We could if we got y by itself initially, we'd end up subbing in and finding x first. But this is how these simultaneous equations always pan out, and yeah, I guess that's the end of the video. Thanks.